So hello students, here I have come again with a new chapter called as triangles. So in this chapter we will solve some important questions related to this chapter, and after solving these questions you will be able to attempt each and every question in a more confident manner. So we will start with some basic level questions, and slowly we will move on to solve some more advanced level questions. So without any further ado, let's start today's session. So here we will start with one new question. So here we see that in the diagram we have been given a quadrilateral ABCD. So let's see what it is given in the question. So AD is equal to BC. It is given in the question, and angle DAB is equal to angle CBA. So now let's see what we have to prove. So we have to prove first that triangle DAB is congruent to triangle CBA. So let's see how it can be done. So first of all, we take the triangles ABC and DAB. So in triangles DAB and CAB, we see that AD is equal to BC, because it is already given in the question. Now angle DAB is equal to angle CBA, means angle A is equal to angle B. It's also given in the question. And we see that the side AB is common to both the triangles. So on the basis of that, we can see that triangle DAB will be congruent to triangle CBA. And we can also check the conditions here. AB is equal to AB means this AB is equal to AB, angle A is equal to angle B, angle A is equal to angle B, and AD is equal to BC. This AD is equal to BC. So these two triangles are congruent by the SAS congruency condition. Side, angle, side. So it was given to prove that triangle DAB is congruent to triangle CBA. So we have already proved the first part. Now let's move on to the second part. Second part, we have to prove that the side BD is equal to AC. Now if we look at the two congruent triangles, we can easily see that this BD side is equal to this AC side. And this is proved by CPCT. The full form of CPCT is corresponding parts of congruent triangles. So we see that since the triangles are congruent, then their corresponding parts will be also equal, and on the basis of that concept we have proved that BD is equal to AC. So in the third part, now come to the third part. Third part, we have to prove that angle B is equal to angle A. This can also be proved with the help of the CPCT concept. So now we can see that how easily we can solve these fundamental level questions. So let's take on some another questions. So here I have come again with a new question. Now let's solve this. So there is a quadrilateral and some sides are given as equal. Those things that have been given in the question I have already mentioned here. So you can see from this, and we have to prove that the side BC is equal to DE. So if we take a look at this diagram, we can see that the side BC and the side DE belong to two different triangles. So let's write those triangles. So side BC, it belongs to triangle ABC, and the side side DE, this belongs to triangle ADE. It means that A, B and C and D, A and E. So it means that we have to take these two triangles, and if we make these triangles congruent, then we can prove that BC is equals to DE. So let's try to make these triangles congruent. So first of all, in triangle ABC and ABE, we can see that the side AB is equal to the side AD. It is already given in the question. So those conditions which are given in the question, we should use those conditions first and then move on to those parts which we have to prove. So first of all, let's start with those conditions that are given already. So here AB is equals to AD, it is already given in the question, so we have written that first. Now let's see AC of triangle ABC. This in these sides, that is the left hand side, I am writing the sides of the triangle ABC. Okay. And on the right hand side, I am writing about the triangle ADE. So in this way, it will be very helpful in observing the sides of the triangle which are mentioned. So we will not be confused anymore. So we see that AB is equals to AD. Now next is we can see that AC is equals to AE. We said see that AC is equals to AE. It is also given in the question. Now, since two sides have been given, so if we find one angle in between these two sides, then it will be very easy to make the two triangles congruent. So first of all, let's see which two angles are given as equal. So angle BAD is equals to angle EAC. BAD means this angle is given, and EAC means this angle is given. So these two angles are given. So by observing this figure, we can see that if we add this small angle, to both the angles, we can make the two angles equal, and then it will be very easy to make the two triangles congruent. So first of all, let's see how to add these two angles. So now, adding angle DAC, let's make this equation 1. So adding angle DAC to both sides of equation 1. So if we add angle BAD and angle DAC, BAD this angle and DAC this angle, so we will get this whole angle, that is angle BAC will be equal to, if we take angle EAC, it will be this small angle, and if we add angle DAC, this small angle, then we will get this whole angle, that is angle EAB. So after observing these three conditions, now we start to write the triangle, and let's see if it is made congruent or not. So triangle, first of all, let's take the triangle ABC. Okay, is congruent to. Now we see that the side AB is equal to AD. So first of all, write AB similar to AD. Then AC is equal to AE. This means AC will be equal to AE, and angle A is equal to angle A. So we see that the two triangles have been made congruent by the condition of side angle side, that is SAS congruency condition. So now it was asked in the question to prove that side BC is equal to DE. So let's see in the two triangles, this BC and this DE are in the same position that has been asked in the question also. So by the concept of corresponding parts of congruent triangles, that is CPCT, we can prove that these two sides are equal. So, like in the previous question also, we have taken the help of congruency conditions and CPCT. Here in this question also, these two concepts proved very useful in solving this question. So let's move on to next question and let's see which important concepts we get to encounter. So here I have come again with a new question, and let's see how it can be solved. So here is a triangle which is given as ABC, BE and CF are the altitudes on the sides AC and AB respectively. So we have to prove that triangle ABE prove that PQ or PO, you can say PQ is the perpendicular bisector of the side AB. It means that we have to